for sharing your valuable knowledge. Now, the next distinguished guest to honor us with her presence is Professor Dr. Zahiraniza Mustaffa. She is currently working as Associate Professor at University of Technology, PETRONAS, Malaysia. She did her PhD from Delft University of Technology, Netherlands in 2011. Her area of expertise is offshore engineering, pipeline reliability, and integrating water resources engineering, hydraulic structures, and urban hydraulics. Ma'am, please try to finish within 15 minutes.
Okay.
Please, ma'am.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Zahira, far away from Malaysia. From Malaysia now is afternoon in Malaysia, and good morning to all the Pakistanis over there. To all respectful, honorable guests and participants of the International Conference on Hydrology and Water Resources, thank you so much for inviting me to give away this keynote speaker on the topic entitled IoT applications in flash flood control systems. So here I'm going to give a case study for the vehicle stability at low-lying areas. So this is a work of a team led by me, and I have graduated Dr. Said Muzamil from Pakistan and currently at Sir Said University as a lecturer. And we are going to graduate very soon another PhD scholar, Ibrahim. Okay, so allow me to bring you to the outline of presentation. I will be sharing with you the problem of the world. When there is so much water, we have to manage it. When there is so little water, we have to manage it somehow. So my strength today is to share with you what happens to the world when there is so much water, which is floods. Floods in the world will be the ideas, and then we'll bring it down, scoping down to flood occurrence at low-lying areas. So that is somehow people forget about. So I'm going to share with you our experience on how we look at this point of view. And then we're going to see how do we bring the IoT applications in flood management and control. Why IoT? It has to be IoT because we are now in the fourth industrial revolution. Whether you like it or not, you are so comfortable with phones, with gadgets. You cannot live without gadgets. Everything has to be within your fingertips. So in our research, in our academic language as well, it has to be translated into those IoT languages. So allow me to share with you one application, one case studies for this scope. But I am never the best person, never the best to talk about in depth on this, but I humbly like to share what we have done so far. Let's see the data. Statistics, we have to be confident in whatever we do. Floods in the world, if you can see here, the blue pie chart, 62%, too much water. 62% of the floods in the world given by different places in the world. Asia is us. Asia is us because we have so much rain as compared to other 4 seasons countries. So we have to know what is happening. Fatalities has gone to up to 45%. 45% of the people died because of floods. So that is Asia. And if we look at all the data, look at the highest peak brought in 1998, 34,000 victims of flood. Some of them are death. So this brought up from the year 1990 to 2018, 195,000 deaths reported. And flood itself, into 2019 in data, it showed to be 197 within a year. Bring you to Malaysia. So this is Malaysia. So that's why we are very in big concern of floods. So these are all the truth, the facts and the truth of all the newspaper cuttings. We have had floods up to the 3-level stories into 2014, if I'm not mistaken. So we had to know, how do we deal with it? We need the rain. We love the water. But how do we deal with it? So this is what happens in Malaysia. Now, looking at the time, I'll bring you to the scope. Low-lying areas. Where is low-lying areas? Why do you have low-lying areas? Somehow, for some reason, you're not aware of those low-lying areas because we are so busy with the urbanization. When we do urbanization, sometimes our roads become depleted with time. And the problem with these roads If our roads here are going down, those are the low-lying areas. And when they are so close to the rivers, it's just like next door, very close by. So these, whenever you have rains, whenever you have rain coming to your river, it will also be bringing the water towards your low-lying areas. So in our context here, it would be on the road. So our focus is on transportation system. Look at that. So this is Malaysia. And I have with you one nice, well, clips here. This is a very strong vehicle trying to go there and then bump, got into the flood. And another one, a very strong four-wheel drive. They thought they could just pass through this road. The low-lying road has been flooded. They thought they could go pass through because it's a four-wheel drive car, but no, it's not the case. So people underestimate the strength of water, the strength of the water velocity, and coupled with its depth. When these two are combined at low-lying areas, you have to watch out. You may not be able to just pass through happily because we want to go home, right? We're just tired of the day. We want to go home. We tried our luck. So it is not the luck. It's not something that you can take for granted. But this is something people forget. But now we are working in detail to find out how do we go about. So these are the data. Okay, fatalities because of vehicle drowning. Okay, now I have showed to you 2 cases just now in those nice video clips. But actually around the world, there has been a lot of fatalities due to vehicle drowning. So these are the data that I'm showing you from Europe, America, Australia, France, Texas, Mexico, USA. Malaysia has not reported yet, but we have the cases. It's just not all countries happen to report. But these are very worrying because it's involving us, the vehicle users. I'll bring you to Australia in 2001 to 2017. So these are the data. Spain, 2008 to 2018. These are the data. And very recently, 2021, this year, 7 March in Algeria. So these are all the data. We're not going to go into details of the stories, but we have to admit and acknowledge worrying that vehicles drowning in floods are getting worse and worse. Why? Because this is the basic. The basic comes from the vehicle itself. Now, when the vehicle is submerged into water, you have to understand there are several hydrodynamics that have to be taken care properly. These are the hydrodynamics on the left-hand side that you can see. That is the car. So whenever you bring your car into the water, be careful because under certain combination of velocity and water depth, you may not be able to cross the road. So we have done a lot of research on this, and we've eventually classified that a vehicle can either float, can either slide, or the worst case, they can topple. So we have equations to describe. We have all the algorithms. And now let's see, how do we bring our expertise of strength in the hydrodynamics, in the equations, into the language of the world? This is the IoT. So in the IoT, the basic IoT, there's a lot of things, right? But I'm just going to make a summary. The IoT is something we like so much because it gives us the quick answers to everything. But in our context for flood management, we can monitor, we can track, we can control, we can sense everything by the use of real-time data. So that is the keyword. The real-time data is the keyword. So that is why people believe and trust in IoT technologies, because we like to know everything in time. But as you go to try to make a framework towards that, you will have to know the 3 things that there are the framework linked together to bring into the right concept. So it's always about the perception of people, the perception of the problem statement, but then you've got to make it into your algorithm of network and then you apply. So that is the basis. So for our side, we will have to know these 3 in order to bring our product into reality. So there are several ways. So as I said, I'm not the best in explaining what are the IoT technologies, but at least the basic for us to know are these, what you are saying now. You need to have sensors, because we are dealing with hydraulics, hydrology. We are dealing with rain, water. That's our best friend. So you need a sensor to be able to measure them. So when you have these sensors, they will be telling you the real-time information. So whenever you have this real-time information, it can be the water depth, it can be the velocity, it can be the frequency. I'm not so sure, up to you. You can select and pick what is it that you want to be sensed, to be monitored. Then you bring it to another technology called Arduino Uno or something else. And as we speak, there are more to come, right? But this, we can visualize the readings, Arduino Uno, and then we bring it into Raspberry Pi. It transfers data to the cloud. You have to bring it to the cloud. If you bring it to the cloud, then people will try to, okay, now we have a topic to discuss, because everything has to be real time, everything has to be big data. You are going to store all your data from little one today, and it is going to be evaluated. It's going to be a lot as time goes by, every second, every hour, every day, every year. So you are preparing yourself towards big data. So you need to have it in the cloud. And later on, with your algorithm, your equations, people will know what you want to sell. So they will be able to capture them in the device. So this is our little story about how we manage vehicles in flat stability. I'll give you the framework. So we have patented this. We call it by flow law, flow in low-lying areas. But our intention is for vehicle instabilities in flats. So this is you in your car trying to go home. So you want to know whether you can pass through this road or not. But in order for you to do so, we, the lecturers, the academic, have the equations, but you need another device to be placed at the site to be able to measure that sudden rise of water level and velocity. So when you have that, we have designed one equipment for that as well. And then from there, it will be able to give the information to our apps. We call it apps, our online virtual IoT things, we call it apps. And from there, you will be able to see. So you are in the car, holding your phone with the apps installed. And what you have to do is like you're going to bring in the information of the velocity and the water depth at that point. And then you put in the apps, and then the apps will say, you are safe to cross. And then otherwise, no, don't. You are going to float, or you are going to slide, or you are going to topple. So the equations will tell based on only two parameters, velocity and water depth. So those are the important thing. Without this framework, we cannot do it. So again, this is a little bit more detail if you are dealing with the road. So you need to have some more information about the condition of the road. And then how do you place your car? Is it going to be really straight adjacent to the water, or are you at a certain angle? So we have made detailed analysis on that, because we have brought our real car into the lab. So this is a car, a cheap car in Malaysia, small car, vehicle. We put it in the lab, we push it under big water in the wave tank, and then we try to see, is it going to slide, is it going to topple, or is it going to float? And we replicate that in numerical software, because we can't afford to have all the cars in the world. But we tried that under certain information on the approaching velocities, approaching water depth. So these are the simulation. You are seeing the waves are moving, so your car is moving as well. So this is the first studies in the world involving moving car in low-lying areas. Okay, so let's go to the other view. So this is a detailed view of our experimental setup. How do we put it proportion to the wave tank, and this is how the numerical supports it. And eventually we prepare a simple diagram, a simple graph, because sometimes you have to transfer your complicated equation into something simple, because you want to use it for the end users. The end users may not see your equation, but from here they will know, am I stable or is my car not stable? So this is the final product that we have. And again, if you want to know more on the sequence, I have explained somehow. We started with the velocity, we started with the water depth. So this is you trying to pass through. So then they will predict the equation, and the equation will say, is it good or not to pass and to go back, or just to stay until the rain recedes. Then only you go back, okay? So finally, this is my last slide, last page. This is how we are developing our apps. So the apps are by the name of Flolo. We are at the final stage of it, and we welcome any potential collaborators, any potential commercialization partners to sell our product in the whole world, because we know the products, there's a lot of fatalities in the world. So but as a simple layman, you have to prepare your apps based on what they think. So you start them to just register and then try to see where they are, where is the flow of velocity and water depth. So they will key in. They don't need to see anything else, but they will just be brought to the next one. Either you are safe to cross, don't, dangerous, don't, you will float. So this is one of the initiatives we are doing back in UTP. But that is our first step towards bringing the technical hydraulics and hydrology into the language of fourth industrial revolution, which is the IoT. Should you have any questions, you can always find me, Zahiraniza Mustaffa from University Teknologi PETRONAS, because we are not able to have a Q&A session now, but you can always email me for anything related to the product. So with that, I thank you.
इरम, आपका माइक ऑफ है.
Thank you so much, ma'am, for sharing your valuable knowledge.